Math isn't difficult. Math is fun. I am Neelakantha Bhanu Prakash and I am the fastest human calculator in the world. And we are Exploring Infinities. Exploring Infinities is here in front of you to give you a mathematics learning experience like never before. With expert trainers from around the country, we are here to make you learn math the right way.
Hello, I'm Anshika from Exploring Infinities and welcome back to our fourth lecture for the chapter Linear Equations in Two Variables. So till now we have done the introduction to our chapter Linear Equations. We studied the graphical representation of our equations and we understood that from a graph we can actually look for the common point of intersection and that common point becomes a solution. We even understood the relationship between the coefficients of our equations. We even understood that somewhere our graphical method of finding the solution fails, so we started looking for other ways of getting a solution for a pair of linear equations. So the one of the many methods that we did was substitution method. So today I'll introduce you to again a new method. It's not substitution, it's a new method. Okay, so in this method is known as elimination method. So in this method, just by listening to the name, you can probably guess you're probably gonna eliminate something from your equation. Elimination method, eliminating something, it makes sense. Okay, so what we do is in this method we'll realize that it's somewhat similar to the model method but not exactly model method. In elimination method you have properly defined steps and you know how to go about it. So let's get started. Okay, so the example that we'll work on for elimination method will be 3x plus 2y is equal to 11 and 2x plus 3y is equal to 4. So this is my equation number 1 and this is my equation number 2. So this is for our reference. Okay, probably we're gonna use it, the equation numbers. So you can look at the equation. So if you try using substitution method, you'll definitely get an answer to it. Okay, so we are probably going to simplify it, because I told you in substitution method what happens is you get probably divides and all if you have coefficients with the variables you choose. So in this method what happens is you first of all choose an variable. In substitution method, you used to first choose an equation and then a variable in it. Here, first of all, you choose a variable, be it x or y. Okay, so I am choosing the variable x in our case. So the first step I did, I chose the variable x. Okay, so now I'll just look at the variable x and their coefficients. So my second step will be look at the coefficients. It's 3 and 2. So if you remember in your example for Dom and Dana's balls, I said that we have 2 balls and 3 balls for Tom and Dana respectively. So we said that we look for the nearest multiple, but it was actually the least common multiple that we were looking for, that is the LCM. So we'll take a look at the coefficients of a variable 3 and 2. So our variable coefficients for x in both the equations are 3 and 2. So we have 3 and 2. So now what I'll do is I'll take the LCM of this 3 and 2, and we know that the LCM of 3 and 2 is 6. So now our first step was choosing the variable. I chose the variable x and then I said that I'll take the LCM for the coefficients of that variable. So my LCM for 3 and 2 is 6. So my next step will be to how to make my 3x to probably to 6x and 2x to probably to 6x. So basically what I'll do is to make this 3x into 6, I'll multiply it by 2. Okay, so I told you when you multiply the one part of equation by 2, you'll multiply the entire equation by 2. So in order to balance the equation. So my third step is I'll multiply my equation number 1 with 2 and equation number 2 with 3. Why? Because I have 2x over here, so I have to make it 6. So obviously 2x multiplied by 3 will give me 6x. So what do I know till now? So my first step was choosing a variable. I chose the variable x. Then I said the coefficients, the LCM of the coefficients was 6. So I tried making my 3x to 6x and 2x again to 6x. So these were my first 3 steps. So now I'll multiply these equations by the number 2 and 3 respectively. So I have 6x plus 4y is equal to 22, and then 6x plus 9y is equal to 12. So I have my equation number 1 transform into this thing, and equation number 2 again to transform into this equation. So we have these two equations now. So we won't look back, okay? Now we have to concentrate on these two equations. So now next is the most important step, where you actually eliminate the variable x. Okay, so my fourth step will be reversing the signs. Okay, so this is the most important step which you actually have to be careful about, because you can make mistakes while reversing the sign. So how do you exactly eliminate a thing? Probably with opposite signs, right? One will be plus and the other will be minus. So what you do here is, the variable you have chosen, that is x, you see what is the sign of that variable in both the equation. So I have plus 6x and plus 6x. So what I do is, I have to make one of them minus. Okay, my fourth step is reversing the sign, so it means either I'll make plus into minus or minus into plus. So I have plus over here, both of them, so I have to make one of them into minus. So we always remember this one fact, that we make changes or reverse the signs in the second equation only. We never play with our first equation. So in the second equation, I'll make all the changes of reversing the signs and all. Okay, so now I have to change my plus 6x of the second equation to minus 6x. So I'll simply write a minus sign over here. So since I have changed the one part of the equation, I'll change the entire, reverse the signs for the entire equation also. And I'll do that to my second equation only. So I have plus 9y, I write it as minus 9y. I have plus 12, so I make it minus. So now my second equation will be minus 6x minus 9y is equal to minus 12. So now you have to consider this equation, not the plus 6x plus 9y is equal to 12. Minus 6x minus 9y is equal to minus 12. Okay. So now what you simply do is, you just simply do whatever you know how to, cancel. 6x minus 6x cancels out. So 4y minus 9y, you get minus 5y. Then you have 22 minus 12, you have 10. So which gives you y is equal to minus 2. So now you have the value for y from here. So now it's simple. Whenever you know the value for one of the variables x or y, just put that answer into your original equation. So I'm just putting it back to my first equation. I get 3x plus 2 multiplied by minus 2 is equal to 11, which gives me x is equal to 5 in the end. So see, I now have the answer for both x and y using a fresh method, a new method known as elimination method. So I want you to look into a few more cases of reversing the signs, because step number 1, step number 2 and step number 3 are something simple that you can do it. You have to just choose a variable, take the LCM of their coefficients and just make them the numbers, coefficients, the original coefficients into the LCM part. Okay, so reversing the signs is actually the most important step. So I'll write, we'll go through a few examples of reversing the sign. So in these examples, I have already performed the step number 1, 2 and 3. Okay, so we now have to directly apply step number 4 for our examples. Okay, so my example is, so 6x minus 2y is equal to 80 and minus 4x minus 2y is equal to 50. So this is my example number 2 that we'll be considering. So in this, as you can see, I have chosen the variable y, performed my LCM part, and I do have multiplied it. So that's why I have same coefficients for my variable y. So it's minus 2y, minus 2y. So again, what we do is reverse the sign, make one of them plus and one of them minus always. Okay, so now we always change the signs of our second equation. So I write plus over here for under my 2y of the second equation. Okay, so now next I change the signs of my other parts of the equation also. So minus 4x becomes plus 4x and plus 50 becomes minus 50. So now simply I just do my calculations. So I have 6x plus 4x, so I write it as 10x, minus 2y plus 2y gets cancelled out. Now this will be equal to 30 because 80 minus 50. So I have x as 3 in this case. So this was one of the cases of reversing the signs. Okay, now one more case. So here again I have performed my first, second and third step, and I have this equation with me. So in this case, you can see first step is performed, second step is performed, third step is performed, my variable is y, I have same coefficients for it. So now the step is reversing the signs. So as you can see, the signs are already reversed, minus and plus. So in such cases, we won't again reverse the sign, because if we do that, they both will have the same signs again, and which we don't want exactly. We want different signs for them. So we already have it, so we simply just do our calculations. So we have 2x is equal to 130, which makes our x is equal to 65. So this is how you do your elimination method, the most important part being the reversing the signs. Okay, so let's do a few word problems. Okay, so my first word problem that we'll do is example number 10. So in example number 10, the question is saying, Mary told her daughter, 7 years ago, I was 7 times as old as you were then. Also, 3 years from now, I shall be 3 times as old as you will be. Find the present age of Mary and her daughter. So the question is saying that 7 years ago, I was 7 times as old as you were then. So she's standing at the present time and talking about 7 years ago. So our task is to find the present age of Mary and her daughter. So whenever such kind of age question comes, it's actually very hit questions among the examiners. Okay, so whenever such kind of question comes, you always, not always, you look at the situation. They are asking you to find the present age of Mary and her daughter. The most simple case is you always take your present age to be x, probably Mary's age to be x and her daughter's age to be y. Okay, let's write down whatever we have till now. So what we have is, we have x as present age of Mary. It's very important that you mention that it is we are talking about the present age of Mary. Okay, and y be the present age of her daughter. Okay, so we have defined x and y. So now the question says that 7 years ago. So 7 years ago, it means whatever your age is right now, you'll minus it by 7. So for example, I'm 30 years old. Okay, so if I'm saying that 7 years ago, so if I ask you 7 years ago, what was my age? So what will you do? You have my present age, that's 30. So you'll suddenly, as soon as I say that 7 years ago, you say 30 minus 7. Similarly, in this case, you start writing one by one, 7 years ago. What will be Mary's age? It will be x, because that's a present age, minus 7. Okay. Similarly, her daughter, it will be y minus 7. So now the question says that 7 years ago, I was 7 times as old as you were then. So she's talking about then age of her daughter. So it means we have to use y minus 7. And 7 years ago, I was 7 times as old as you were then. So it means according to our question, we have x minus 7. I was 7 times as old as you were. So this will be equal to 7 times y minus 7. So if you try simplifying this equation, you'll get x minus 7y plus 42 equal to 0. So here we have our first linear equation in 2 variables. Okay, so I'll give this equation number 1. So again the question says 3 years ago. So next is 3 years ago. The first step you'll do is you'll first write it's talking about 3 years from now. Okay, so it's 3 years later. 3 years later, what will be Mary's age? Whatever her age is right now, plus 3, and daughter's age will be whatever her age, that is y plus 3. So we have our 3 years later age of both Mary and her daughter. So now the question says, I shall be 3 times as old as you will be. So I, that is x plus 3, will be equal to 3 times y plus 3. So we write according to the question, x plus 3 will be equal to 3 times y plus 3, which will imply our equation to become x minus 3y minus 6 equal to 0. So here we have our second equation, linear equation. Okay, so now we know what to do. We'll apply our elimination method that we have just learned. Okay, so I'll choose a variable. Probably in this time I'm choosing y. Okay, so my variable I'm choosing is y. So my second step is take the LCM of my coefficients for y, that is 7 and 3. So I have LCM as 21. Okay, so now I have LCM also. So my third step will be making my 7y into 21y and 3y into 21y. So what I do is I multiply my first equation by 3 and second equation by 7. Okay, so when I multiply it, I get 3x minus 21y is equal to minus 126, and I multiply second by 7, I get 7x minus 21y is equal to 42. So now I look at my y part, I have minus 21y minus 21y. So I reverse the sign of my second equation, that is into plus. I change the sign of the entire equation now, so plus 7x becomes minus 7x and plus 42 becomes minus 42. So I simply cancel this part. I have minus 4x is equal to minus 68. From here I have x is equal to 42. So it means the present age of Mary is 42. So now you want y also. So you just substitute in any of the equations. So I'm substituting my first equation. So I have x as 42 plus 42, my constant, is equal to 7y. So I have y is equal to 84 by 7. So my y will be 12. So it means Mary's age is 42 years. 42 years and her daughter's age will be 12 years. Do mention these units in your questions whenever they appear. So now if you remember, in the last class we did example number 8 and 9 also. So in those equations we learned how to get the equation out of our word problem. So now we quickly solve example number 8 using our elimination method. So we know that our equation that we formed was x plus y is equal to 25 and 50x plus 100y is equal to 2000. So if you remember, she had 50 and 100 notes. The total number of notes she had was 25, which makes our equation number 1. and then she said that probably the number of 50 nodes be x and number of 100 nodes be y. So when you multiply each with 150, you get total of rupees 2000 rupees. So that's our equation number 2. So now we have to choose again a variable. So I am choosing the variable y probably in this case, because even if you choose x in this case, it's like LCM of 1 and 50 only, and y also LCM of 1 and 100, it's 100 only. So it's like multiplying just your equation number 1 probably. Okay, so I'm choosing my variable y in this case, and my LCM for 1 and 100 is 100. So what I do is I multiply my first equation by 100, and second equation I don't have to multiply it by anything, I just have to multiply it by 1. That's just simply that very same equation. Okay, so I multiply my first equation by 100, I get 100x plus 100y is equal to 2500, and I get my second equation as 50x plus 100y is equal to 2000. So you have multiplied your equations. Now your next step is reversing the signs. So you can see my signs for the variable y, plus 100 plus 100. I'll change the sign of my second equation to y. Similarly, I change the sign of my other parts of the equation, that is minus 50x and minus 2000. I simply cancel out my 100y minus 100y. So I have 50x equal to 500. So from here I can say that my x is equal to 10. So when my x is equal to 10, I just substitute in my first equation, is the easiest. So 10 plus y is equal to 25. I have my y as 15. So this is how you solve your elimination method. And from word problems, whatever equation you get, you can either use substitution method or elimination method. Both are easy. Just have a look at, probably substitution might be easy. For example, in this case, example number 8, you didn't have to actually use elimination method. Probably substitution was easier. And in such cases, for example number 10 also, you could have used elimination or substitution. It always depends upon your convenience and the question. Okay, thank you.
And so we come to an end to today's lecture. Thanks a lot for watching this, and stay tuned for the upcoming ones. Don't forget to follow @fastesthumancalculator and @exp.infi on Instagram, and subscribe to our YouTube channel.